Topic 3, Section 4, and it's called Arithmetic Sequences. A sequence is an ordered list of numbers that often form a pattern. Terms are the numbers in the sequence. So you see an example 1 here. You see an example of a sequence of numbers. It's just a list of numbers. We would say that each one of these is a term in the sequence. Okay, it's an arithmetic sequence if each number in the sequence has a common difference. So if you can see where we're adding or subtracting the same amount each time in the sequence, that makes it an arithmetic sequence. So if you go from -4 to +1, you're adding 5. If you go from 1 to 6, you're adding 5. If you go from 6 to 11, you're adding 5. So since it has a common difference, you see the same thing added each time, you would say yes, this is an arithmetic sequence. And then it says if so, if it is, you're going to name the next two terms in the sequence. So I would continue the pattern and keep adding 5, and I'd say 21 and 26 would be the next two numbers in the sequence. When I look at example B, I'm increasing by 2, then I'm increasing by 4, then I'm increasing by 6. So we see a pattern, but we don't have a common difference. It's not the same number each time that we're increasing by or decreasing by. So this is not an arithmetic sequence. It's still a sequence of numbers, it's just not an arithmetic sequence. Okay, we're going to look at two things. We're going to look at the recursive formula and we're going to look at the explicit formula. Okay, and you're going to need to know both of those. Now, in finding the recursive formula, I think sometimes the fact that we have a formula makes it a little bit almost confusing to you. Here's the recursive formula. What it says is if you want to find the next number in the sequence, so let's just say I have a sequence of 1, 2, 3, 4, 5. I want the 6th number in the sequence, then this would be a of 6, a sub 6. If I want the next number in the sequence, I'm going to just take a to the n minus 1, means one term before the one you're looking for. So you take the last term that you know and you apply the common difference. You add d, or if the sequence is decreasing, you would subtract d. So what I do here is to write the recursive formula. I just say the next number in the sequence is going to be equal to the previous number in the sequence plus whatever d is. The only thing you're adding to the recursive formula is the common difference. So you look and see what's happening between the numbers, and I can see each time it's increasing by 13. So my recursive formula would just look like a sub n equals a sub n minus 1 plus 13. This is the only value you add to it. If I look at what's happening in this sequence of numbers, each time I'm decreasing by 8 each time, so my recursive formula would look like that. You just put a -8 at the end. And that's all you're doing for the recursive formula. For the explicit formula, you have a different formula that you're using. It's given right here. And for that formula, you need to know the first term of the sequence, the number term you're looking for, and the common difference as well. I'll leave that up so we can see both of those. To write the explicit formula here, we start out with a sub n equals. We have to have the first number in the sequence first, so that would be a -12 in this case. And then we would say plus n plus 1, n minus 1 is the formula. And then it's times the common difference. You have to look at the sequence and determine what the difference is. Each time it's going up by 7. Now this is multiplication back here. So we are going to have to distribute the 7. So we say a sub n equals -12 plus, I would get 7n minus 7. And then you want to simplify the terms that are like terms. So I have a -12 minus 7. That's going to be a -19 plus 7n. So this would be your explicit formula. And then it goes on, you're going to use that to find the 100th term. A with the subscript of 100, you're finding the 100th term. So you're going to plug that into your formula and say the 100th term is equal to a -19 plus 7 times 100. N is your term. You're going to do the math, -19 plus 700. You're going to get a value of 681. So if I were to list out all these terms until I hit the 100th term, I'd be at 681. Okay, if I want to do the same thing here, writing the explicit formula, I have to start with the first term, which is 5, plus n minus 1 times the common difference. Each time it's going down. This time it's going down by 6, so my common difference is a negative 6. Okay, you're going to distribute here. So you're going to get 5 plus a negative 6n plus 6. Negative times a negative is positive. You can combine these terms to get 11 minus 6n. That would be your explicit formula, and then if you want to find the 100th term, you're going to plug in 100 for n. Say 11 minus 6 times 100, 11 minus 600, and you're going to get a negative 589. So if I listed out 100 terms, I'd be at a negative 589. A couple other things you're going to be asked to do is you're going to be asked to write the explicit formula, and they will give you the recursive formula. Keep in mind that when we use the recursive formula, the only thing that we plugged in was the common difference. So when I convert this to an explicit formula, I have to have the first term of the series, which is given to me in 10, and then I would say n minus 1, and then it would be times that common difference. That's the only value that I'm taking out of the recursive formula and using when I convert it to an explicit formula. You're going to distribute. So 10 plus, this would be a negative 3n plus 3. You can combine your like terms and say 13 minus 3n. You can do the same thing with letter B there. When you're writing a recursive formula from the explicit, here's the explicit formula, and if you'll notice that the common difference that you're using is always ending up being the coefficient in front of n. So if I look at what the coefficient is in front of n here, that's a half. So I know my common difference is equal to 1/2. That's what I take off of the explicit formula, that common difference. And that's the only thing I need to write the recursive formula. The recursive formula is just a to the n minus 1 plus the common difference. So in this case, it would be plus a half. Now, when you want to find the first term in the sequence, we're always using the explicit formula to find a particular term in the sequence. So if I want the first term, that would be n is replaced with a 1 because it's the first term, and you would also put a 1 in for n. So you're going to multiply here, and you're going to say 1 plus a half. Add those together. The first term is equal to 1.5, or you could write that as 1.5, or you could write that as 3 over 2 is also 1.5. Okay, and then the last example here that we'll look at, we can use this when we're talking about everyday situations. When you're looking at this table, the number of days, you see how it goes from 1, 2, 3, 4, and on up. That's your number of term. So I could convert this to a sequence by just using the y values or the rental cost. And the day is my number of terms. So this is going to keep going up. And you can see that we have a common difference each time. That common difference is 12. It's going up by 12. So it says, how can you represent it using an explicit formula? Okay, with the explicit formula, you start with the first term, plus, and it's n minus 1 times that common difference. So we're going to distribute the 12. I would get 26 plus 12n minus 12. Combine your like terms, and your explicit formula would be 26 minus 12 would be 14 plus 12n. That's how we would leave our explicit formula, and then we would go ahead and use that formula to answer the question B. It says, what is the cost of renting a bicycle for 10 days? So I'm going to plug 10 in for n, and say on the 10th day, or the 10th term, that's going to be equal to 14 plus 12 times 10. Okay, that would be 14 plus 120, and it would be equal to 134. So I would be spending $134 on the 10th day. Okay, that's your arithmetic sequence. Go ahead and see if you can complete that worksheet.